concept of physics. Today I would tell you about the electric fields associated with conductors or metals, and I've seen that most of the students have doubts about that. So let us discuss the electric field associated with conductors. So first of all, I would like to introduce a term which most of the students know: permittivity. So permittivity of any medium is the ease with which that medium allows the passage of electric field lines through it. It means how easily that medium permits the field lines to pass through it. Yeah. So this is permittivity, and we know that permittivity of vacuum is 1 and permittivity of conductors or metals is infinity. So the highest permittivity is owned by metals. What does it mean? It means that I've taken an example that let's suppose there is a point P situated in vacuum, and we have applied the electric field E external here. Field is uniform, hence it is denoted by parallel equally spaced lines, and at P therefore the field will be E external. Okay. Now if we put a sphere here, such a way, metallic sphere, such a way the P is the center of the sphere, then what will be the effect at P? What will be the effect on electric field at P? So I would say, and you all know, that electric field at P will become 0. But I am raising a question in front of you, which most of the students have this question in their mind, that as we know that permittivity of metals is infinity, so conceptually metals should most easily allow the passage of electric field lines through them, and theoretically its value is infinity, which also means that if this metal was not present here, then the field at P would be E external, and if this metal is present and P is inside that metal, then the electric field at P should still be E external. And why I am saying so? Because the permittivity of metal is infinity, which means that metal easily allows, and metals exactly allows the field lines to pass through them, and hence any point which is situated inside the metal should have the same field as was in vacuum. Okay. Now, but we are getting a contradictory result, and it is creating a paradox that although the field, the permittivity of the metal is infinity, the field inside the metal is 0. How it is possible? It is just opposite to the definition of permittivity. So I will explain the secret behind this logic. So first of all, I would like to tell you, then whenever we apply an electric field on any medium, either that medium is conducting or that medium is non-conducting, some electric field is induced in that medium due to movement of and due to polarization of charges. Like if we apply this electric field on this metal, the electrons which are experiencing a force in the opposite direction of electric field will move backwards, and the positive charge will move in the opposite direction of electrons. Hence, a polarization of charges occurs. You can see. Hence, there would be an induced electric field in reverse direction from plus to minus. Actually, induced electric field has a nature that it is always induced in the opposite direction of electric field, external electric field, and it is quite obvious this happens because the electrons actually move in the opposite direction of external field. Therefore, the induced field will be induced in the opposite direction of external field, and by definition, as the metal has infinite permittivity, I would say the effect of external field inside the metal is exactly the same as it is in vacuum outside the metal. And I am saying that this field has the same value at P, E external. But when we draw a field line, then field line represents the net electric field, not an individual electric field. Likewise, I am stating that if there are 4 charges in this room and we have to draw a field line on the center point. So, field lines are defined as the movement or as the path of positive point charge or test charge at any point. So if we keep a test charge at center point, it will only move in a single direction, and that single direction would be the direction of net electric field due to these all charges. Okay, so electric field lines cannot intersect each other, and electric field lines represents the net electric field. So if an external electric field is also present here and an induced electric field is also present here, then the net electric field would be something different. Now I am coming on the magnitude of induced field. We have heard about this formula, or maybe you have not heard about that formula. The induced electric field in any medium is equal to minus of external electric field into 1 minus 1 upon epsilon r, where epsilon r is the dielectric constant of that medium in which field is being induced. Likewise, we are talking about induced field in metals, so we would take the dielectric constant of metal, which is infinity, we all know. So, and this negative sign indicates a very important fact, that induced electric field is always induced in the opposite direction of external field. So there are two things. We all know that epsilon r is greater than 1. So this term would be less than 1. And this complete term would also be less than 1. Hence, induced field would be less than external field, except in one case. And induced field would be exactly in opposite direction of external field. Combining these two facts and applying them on metals, we know that for metals, epsilon r is infinity, and therefore by keeping this epsilon r here, we get induced electric field is equal to minus of E external, which is a very important fact which will erase this paradox, that in metals induced electric field and external electric field are exactly the same in magnitude and are in opposite directions to each other. So the net electric field in the metals would be 0. So when we are talking that does the metals do not allow the passage of electric field lines through them, we are exactly not correct. In fact, we are wrong, because the permittivity of metals is infinity, and obviously hence metals allow the passage of external field through it quite easily. But then also the metal has net 0 electric field in it. So when we are talking about the electric field inside the metal, we are not concerned about the induced electric field only, or we are not concerned about the external electric field only. In fact, we are concerned about the net electric field. So net electric field inside the metal is 0, as induced field and external field cancels each other because they are equal in magnitude and opposite in directions, and hence the field lines are not drawn inside the metal, because field lines represents net electric field, not any individual electric field. So there is a unique relation. E induced is equal to minus of E external into 1 minus 1 upon epsilon r. And if in any medium we wish to calculate the magnitude of net electric field by this formula, so we can write that net electric field is equal to external electric field minus induced electric field. And I am using this minus sign, and I am already assuming that induced electric field is in opposite direction of external electric field. You can also solve this equation in vector form, and if you use this induced electric field in vector form, then automatically this minus sign would come here. Okay, now net electric field is E external minus, now I am taking the magnitude of induced electric field. So without this negative sign, I have to keep this magnitude here, and it would cancel out, and net electric field will be equal to E external upon epsilon r. And for this conclusion, we can write epsilon r as infinity here, and by putting epsilon r as infinity, E net would be 0. And therefore metals have zero electric field in them, and we are referring electric field as net electric field. Okay, and metal has infinite permittivity. So this is the bridge which erases the paradox of two facts, that metals have infinite permittivity, then they should permit the passage of electric field lines through them, and then also the net electric field in metal is 0. So I hope you enjoyed the video, you got to know something.